Good morning, YouTube. Today, we're going to continue on with the 355 engine rebuild project.
So are you recording all of the nefarious activities?
If you're new to the channel, my name is Dan, and that is Josh. And we're going to learn some more stuff about these 355 engines because, well, he knows them and I don't.
Yahtzee.
So anyway, real quick, if you guys would like to support us, please like, share, and subscribe. Hit the notification bell. And of course, go visit normalguysupercar.com. And better yet, go visit his website for his shop. That is exotic-powered.com. He does all sorts of work on Ferraris, Lamborghinis, and other exotic cars. Thus the name Exotic Power and Performance. It's like you meant to do that.
Sometimes I think before I speak.
I saw that one computed for a second. There it is. Anyway, we got to get the heads taken care of, and then it's off to the machine shop.
We're going to get some heads today.
Oh, God. Oh, man, it's going to be a bad day. All right, well, we're going to keep going with this. You guys have been asking for it. Here we go. We're going to continue working on this 355, and hopefully this will be kind of the last of the teardown, and then it's off to machine shop, and then we start building it back up. Okie dokie. So the valves, the valve guides, that is the notorious problem on the 355, and this engine clearly, we think, suffers from that same problem.
Correct. And this will be kind of a fun discovery because, you know, valve guide wear has varying degrees. You've got your valve stem.
Mm-hmm. Where it's shiny.
Yep. And notice how it's undercut. So this area would be exposed in the port. Yep. So it's been turned down to a smaller diameter to allow more airflow through, so it blocks less of the air
Just
passage.
the tiniest bit.
Yep. So you can see the sharp line right here.
Yep.
Where they start to taper it down. So that part of the valve stem, right, and I'm obviously speaking as if whoever's watching this doesn't know anything about how an engine works. And then inside here, you've got the valve guide.
Yeah.
Okay, so
Where
the
it
guide,
actually goes.
Yep, so the guide is a sleeve made of, in this case, a bronze material that will have copper or manganese or some other, you know, metal mixed in there, right? Some engines have steel valve guides, all of that. So you have the aluminum head, and then make sure you don't permanently destroy the aluminum cylinder head, or really any cylinder head in general, right? You have a metal insert here, which is your valve seat, and then you have this metal insert sleeve here, which is your valve guide. Yep. So that way the valve is never making contact with the head itself.
With the aluminum.
Yeah, and
Gotcha.
that obviously makes the valve work properly and allows us the opportunity to have wearable materials that are replaceable, because this is under quite a lot of duress when the engine's running.
I would imagine.
What'll happen, right, is the metal that your valve is made out of is going to be a pretty hard material, right? Whereas the guide is going to be a much softer material and considered sacrificial. So that's why you get guide wear issues. And also, there's no way to actually force feed oil into these guides, right? So any oil that gets into the guide is basically through splash and dribble, to the point where you have the valve stem seals up here, which are Teflon with a spring to keep a little bit of a fit on this to make sure that there isn't any excessive amount of oil passing through the valve stem and the valve guide into the combustion chamber.
Right, yeah, because you don't want it leaking by.
Right, because on very early engines, right, they blow blue smoke. Like if you watch videos 1920s and 30s and maybe even 50s and 60s era engines, right, you'll get a lot of oil blow through here and they always smoke. Brand new, perfectly built engine, it's going to smoke because you don't have valve stem seals, or you have, you know, really high clearances between the size of the valve stem and the ID of the guide,
right,
because of manufacturing and material, you know, qualities back then. So old engines are known for smoking, and that's a large part why. Piston rings and other things, you know, contribute, but this is a large factor. So on modern engines, where we're more concerned about cleanliness and emissions in the environment, now we have better quality materials, tighter tolerances, stem seals and things to keep excessive oil out of here.
Right, right.
But that means that now you need to have a material, soft material guide, which has a natural lubricity to it, which means it's sacrificial and it'll wear. So like a race engine will have even softer bronze guides.
Yeah, because they don't care if it lasts very long.
literally, it only has to last through the one race or whatever. They're more concerned about the resistance, right? The friction between the valve stem and the guide, right? Because that costs
and
horsepower.
Ferraris are basically street legal race cars, so they're using race technology in a street car, which means you get lots of maintenance.
Exactly. And so that's where the issue came in the 355s, right? Is you have a 5-valve per cylinder design on a small bore.
Yep.
So you have a lot going on in a small area. So one can assume that there's going to be a great deal more heat because you have more moving parts in a small space compared to if this was a 4 or 2 valve design.
Yep.
And they probably used too soft, right? In the books, it says it was a copper bronze, not a manganese bronze guide. So the guide material was probably too soft, which is great for lubricity and encouraging horsepower, but terrible for longevity and preventing wear. So literally, when the valve is sliding up and down the guide, it's slowly wearing away material, right? Because your valve, as the camshaft acts on it, your valve is doing this at,
Really fast.
yeah, yep. So eventually it takes material away.
Yep.
And there's a point at which this becomes a problem. On this motor, it's got quite a lot of miles, right? And it ran half decent, but we had some wonky compression numbers.
Yep.
And we know that valve guides are a concern on these motors. But also when we tore the motor down, we found that we had some really heavy wear in the cylinders and the piston rings in the cylinder walls. Since we didn't do a leak down on the rotating assembly after the heads were off, right, we could have made it an adapter plate and pressure tested just the piston rings without the heads on and tested the leakage through the rings. And then that would give us another data point on whether our leakage is going to be through our valves versus our rings. But frankly, we didn't care because the numbers were bad enough that the engine needed to be serviced.
Right.
So
we knew we were going to do the rings and cylinder liners.
Pretty much. So we saw what I considered a little more wear than I thought we would see in the cylinders. So now I'm curious how much of our bad compression numbers and stuff we had was rings and cylinders versus actual valve guide wear.
Right.
So
those might not be as bad as we initially thought.
They might not be as bad as we thought. I've had motors where we've pulled them apart and the tolerance here is about 1.5 thousandths. So the ID of the guide should be 1.5 thousandths larger than the OD of this valve stem.
Right.
So that way there's some clearance, allows for oil and expansion and contraction as the valve heats up and all of that. You can go up 1/2 thou or so, right? So you can go from 1.5 to 2, maybe even 2.5 thou, and consider that the upper limit of reasonable clearance.
Right.
And anything over that is excessive, and now the valve's going to be moving around, and you're going to get, uncontrolled valve action, and it's going to cause all kinds of vacuum and combustion chamber, performance issues, and then it's going to start beating on the valve stem seal, which allows leakage, which contributes partially to the high compression numbers we found on those 2 cylinders where the rings are oversaturated in oil, right?
Yep.
There's a lot of other stuff involved with cylinder head stuff that we're not going to deal with. There are things as far as shimming the seats for the valve springs, so that way the valve springs are a specific height when they're installed, so that way there's a certain amount of preload in them, and that way they have the correct amount of tension and travel. Same thing with the valves, right? There is a spec for the distance between the end of the stem and the face of the valve, right? So when the seats are ground and the valves are surfaced, it moves the valve up into the cylinder head.
Oh, yeah.
So you have to take a little bit off the tip of it, so that way your lifter bucket
Just nip
isn't...
the tip.
Yep, nip the tip, so that way you don't push your bucket too far into your camshaft.
L'chaim.
And then similarly, you may have to add shims underneath the valve springs here, because everything's moved up. So to maintain the correct height.
Everything has to go up because the position of the valve moved up.
Correct.
Yeah, that makes sense. That's some interesting geometry there.
There's a lot there, right? As well as just the geometry of the valves themselves in the head and making sure that the guide is on the same plane as the seat. Because if the seat is off, right, now you're not going to get good sealing and you're inducing bending into the valves, right?
Bad things.
Yeah, there's a lot of stuff. And then you have concentricity of the holes here for the lifters, right?
Yep.
You want to make sure your lifters are more round than oval and that your bores here are more round than oval. You've got the diameter here.
The camshaft bearings.
Yep. And there's a clearance there as well as what you call the line bore and making sure these are straight and true. You've got the head surface, that's supposed to be flat and true and square, as well as, you know, a specific roughness. There's a great deal that goes on in doing cylinder head work, and I am not a master cylinder head machinist, so that's about as far as I'm going to go into detail about all the specifics in the cylinder head. And frankly, a lot of it's irrelevant to us right now because as far as we know, this is a factory machined and assembled cylinder head and there's no obvious signs of problems aside from our suspected guide wear. So I have no reason to worry about all of these other dimensions right now.
Yeah.
Basically, the way we look at this from a very practical standpoint in a service shop, you know, not a professional race team motor, is everything seems fine. So we're gonna verify all of our guide wear, partly for the sake of the YouTube.
Right. Like if you were at home, you'd probably just send it off.
Exactly.
You'd be like, we'll assume they're bad. Go machine it.
Exactly. Or you just pay the machinist to check all of these things we've just discussed and then tell you whether or not it needs to be addressed or it's fine and just put it back together. And similarly for us, right, we're going to do this valve guide wear check for our own entertainment and for the YouTube. And then if everything's fine, well, then maybe we just clean the heads up and worry about refreshing the bottom end and move along. And if it's not fine, it doesn't matter what any of the other dimensions are, because when my machine shop replaces the guides and grinds the valves in the seats, he's going to have to check, you know, the valve stem heights and the spring and, you know, valve spring installed heights. And he's going to have to check all that stuff and make sure that it's all, you know, copacetic. And that's his problem, and he has the right equipment to do that. We've been through a few engine jobs together, so I know that I can trust his communication and his professional opinion. We're just gonna do valve guide wear check because that's the big topic for 355s. We're not gonna do a full dictation on how to build a, you know, cylinder head. That's a conversation for another day on another project. So there's a bunch of twats out there that don't like the fact that I was using a caliper to do bottom end measurement, and that's a fine and valid argument, and I don't care. But for today, we're dealing with small parts and small dimensions. For this, I'm worried about more than a half thou difference, right? On the bottom end, visually, everything was fine. Accuracy within a half thou or...
I'll say, wasn't it like 1.5?
Yeah.
So we had a much larger range, 300% larger range.
And we're dealing with larger diameters.
Yeah.
So there's also a scale of accuracy sometimes, right? So you have the tolerance itself, and we're measuring, you know, 2-inch diameter parts at a thou and a half, you know, tolerance. A half thou of accuracy in my measuring equipment was not critical. But now we're dealing with something very small and, you know, small tolerances. So now I'm gonna, you know, do the right thing and be a bit more particular about what we're gonna do.
Ooh, what is that?
This is what we're going to use to do our measurements.
Oh, okay.
So how does one do valve guide wear measurements, right? Obviously we have the book specs and all of that stuff. We're Americans, so we're gonna use inches today, and we're gonna keep this quick and simple. Right?
Bald eagle nuts.
Bald eagle nuts. So we will take the valve stem itself, okay?
0.2349
inches. So we're gonna write that down, right?
All right, I'm gonna write it down.
0.2349, right?
Yep.
We take this little guy.
Yep.
See how it's got kind of a bald.
Whoa, there it is, yeah.
There's a tapered mandrel in here. See that, how it...
Oh, it expands it.
Yep.
Wow.
So we're gonna run it inside. Okay, so it's all loose. So
Go ahead until it's tight.
yep, nice positive drag, right?
Yep,
So you
yep.
need tension on it. Okay,
And then you measure that.
and now we'll measure this.
Should be slightly larger. 0.2376.
Yep. 0.2376 will be guide 1.
So the difference, 0.0027. Wow. Okay.
Okay, so our clearance is almost 0.03, right?
And you said a half. Or
Yeah, I think 1.5 to 2 is ideal. We can look it up in a little bit. So that's an idea of how, we're going to do the valve guide clearance checks. So that was one intake valve. Okay, so now we'll do the opposing exhaust valve because the exhaust side usually takes in more wear.
Oh.
Because there's a lot more heat on the exhaust side of the combustion chamber.
Ta-da. Valve.
There's the exhaust valve.
Yay.
Another cool tidbit about the Ferrari's dual valve springs.
Yeah. That's cool.
Yeah, different rates, different heights, so that way you get more control. So now, right, we're not working in absolutes where we're just going to go by book numbers on this. We want to actually measure each individual part, 2, 3, 4, 5. And now
Stick it in the hole.
I'll go down the hole. All right, so I'm happy with the amount of resistance,
Yeah.
2370.
All right, so that one's got a difference of 0.0025.
So that's not the worst I've ever seen. I've seen 9 thousandths worth of
Whoa.
clearance in a set of heads I had done once. Yeah, in a car that were in perfectly fine before we
of course.
pulled it apart and checked it.
Right,
so
right.
that's actually not bad. But we will double check the book specs and see what our tolerance is supposed to be. So valve stem spec, right? There's always a range because nothing's ever perfect in life.
Right.
So 2350 plus or minus a couple of tenths is spec. Valve stem 1 we measured 2349, which is right in spec. The exhaust valve was 2345, which is just a hair under spec.
Yep.
Not such a big deal. So here's our valve guide. So our range is 2364 to 2370.
Yeah.
Our intake guide was 2376.
Too big.
Yeah, so we're a half thou over maximum spec.
Yep.
And the exhaust guide was right at 2370, which is, factory upper limit.
Yep.
But more importantly is our clearance, which is 1,000ths to 2,000ths.
And we're over on both.
2.5 to almost 3,000ths.
Yep.
Yep.
Okay.
So
Shoot. So they're bad.
yeah, I mean, for the mileage that's on the motor,
It's actually pretty decent.
yeah, that's not bad. But since we're pulling it apart to service it, these are out of spec clearances. So,
Right. And
yeah.
we've already expected that, so it's already kind of baked into what we're going to do.
Exactly. I was expecting worse numbers,
Yeah.
and we might find worse numbers in some other cylinders. The wear is not perfectly consistent through all components at all times. We're at least outside of normal specification by a full thousandths, you could say, right? Because if the range is 1 thou to 2 thou clearance, that means you're shooting for a target of 1.5 with a half thou plus or minus variance, because again, you can't ever achieve truly perfect tolerance when you're machining. I could argue that we're a full thou bigger,
Than you really want.
yeah, full thou to thou and a half bigger than what we really want to be for an ideal tolerance.
Just confirms that we needed to do the valve guides.
Yeah, it's got wear in it. Yeah.
Okay.
But the what's important to note here is this is at 60,000 miles, 70,000 miles this car
80.
has, 80,000 miles on it, right? And we're just outside of spec. So
pretty
I've
good.
pulled apart motors like my car, my black car with
Yeah.
20,000 miles, 15 to 20,000 miles, and we've had 8,000ths clearance on the valve guides.
Wow. So it's kind of hit and miss.
Yeah, that's why there's a lot of debate over model years and all of the blah. My car's a 97 or 98. It's a later
this
car.
one.
Yeah. So is this one, right? My car has 20,000 miles on it, and this one has 80,000 miles on it. Mine badly needed guides done. This one, this is perfectly acceptable wear for the mileage on the car.
Yeah. All right, YouTube. So as you can see, well, the valves were actually in better shape than we thought, but still need to be replaced, so we're gonna do that. Those heads are gonna go out to the machine shop. It's gonna be a couple weeks until they come back, and once they get back, we gotta replace the cylinder liners in the block, and then we actually start reassembling this damn thing, and hopefully stuff will go fast then. So this is kind of like the last major thing we had to do. So again, a huge thanks to Josh. You can hire his services at exotic-power.com. We can't thank him enough. He's done so much for us. And of course, go visit normalguysupercar.com and please like, share, and subscribe. That does help us out. Yeah, hopefully we'll have this thing running maybe a month or so. It's gonna be a little while because, well, yeah, stuff's still gonna take a little bit. We'll see you guys in the next video. You know you're gonna wanna stay tuned for some, yeah, going up.
Say it 10 times fast.
Yeah,
Dan.
right. We got some cool car stuff coming your way, so you're gonna want to stay tuned.
Peter Piper picked a pack of pickled peppers.
Yeah, dude, I usually just rolls off once in a while I screwed up.